Welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about S parameters and properties of S matrix. Okay, let's start with two-port networks. So two-port networks are often described by using the Z, Y, H or ABCD parameters. So these parameters are used to analyze the two-port networks. So these parameters are used in low frequencies. So drawbacks of these parameters: at microwave frequency, total voltage and current are difficult to measure, and ideal open and short circuit terminations are difficult to realize at microwave frequencies, and active devices may oscillate under the open or short circuit condition. So these are the reasons these parameters cannot be used at microwave frequencies. So we use S parameters for high frequency analysis. So here incident and reflected waves are being monitored. Resistive termination is employed and active devices are normally quite stable under resistive termination. So these S parameters are characterized by incident and reflected wave amplitudes. So it is given as A1, B1 and A2, B2 at port 1 and 2 respectively. So what are S parameters? So S parameters are measured by sending a single frequency signal into the network and detecting the wave exit from each port. So power, voltage and current can be considered to be the form of waves traveling in both directions. So incident wave and reflected wave is considered, and for a wave incident on port 1, some part of the signal reflects back out of that port and some portion of the signal exit at other port. So we have a reflected wave and a transmitted wave. So let's look at S11. Here the S parameters is characterized as S11 at port 1. So it refers to the signal reflected at port 1 for the signal incident at the same port. So scattering parameter S11 is the ratio of the two waves, reflected wave divided by incident wave. So it is B1 by A1. So now take S21. Here S21 refers to the signal exiting at port 2 for the signal incident at port 1. So scattering parameter S21 is the ratio of B2 by A1. So B2 is the transmitted wave at port 2. A1 is the incident wave at port 1. Now S22 refers to the signal exiting at port 2 for an incident signal at port 2. So it is the ratio of B2 by A2. And S12 refers to the signal exit at port 1 for an incident signal at port 2. It is the ratio of B1 by A2. So a linear network can be characterized by the set of simultaneous equations describing the exiting waves from each port in terms of incident waves. So the four S parameters are defined as S11 equal to B1 by A1, similarly S12, S21 and S22. So S parameters are complex in nature. They have magnitude and angle because both the magnitude and phase of the input signal are changed by the network. So this is why they are sometimes called as the complex scattering parameters. So here we can write the equation of scattering parameters. So B1 equal to S11 A1 plus S12 A2. So for a two-port network we can define as matrix format. And for a multi-port network, here we consider 5 ports. So from port 1 to port 5. So for this 5-port network, we can write the S matrix from B1 to B5. And similarly, S matrix is 5 cross 5 matrix and A1 to A5. So incident waves. So scattering parameters for the two-port network can be derived using the open or short circuit method. So here S11 equal to B1 by A1, it is calculated when A2 equal to 0. So it is known as reflection coefficient. And S21 is B2 by A1, it is known as forward transmission coefficient. And S12 equal to B1 by A2, it is known as reverse transmission coefficient from port 2 to port 1. And S22 is the reflection coefficient at port 2. And let's see the properties of S matrix. So first of all, let's take the M port network. So it is always a square matrix with order M cross M. For M number of ports, we can write S matrix as M cross M matrix. And another properties are, for a lossless network, S matrix is always unitary. It means the matrix multiplied by its conjugate matrix equal to 1. That is, identity matrix is taken in the matrix form. So S into S conjugate equal to I. So S can be written as Sii, Sij, Sji and Sjj. So this is the S matrix. And we can write the complex of the matrix, complex conjugate of the matrix, which is equal to unity matrix 1 0 0 1. Similarly, for n port network, we can write the same equation. And another property is the S matrix is symmetric for all reciprocal networks. So here the two matrices are equal, S equal to S transpose. So it is the symmetric matrix. So we can write the matrix equal to transpose of the matrix, or Sij equal to Sji. So we can write the unity matrix in two ways. Summation of Sij star equal to 1. Here the same row and same columns are taken, and another format is summation of Sij Sik star equal to 0. Here the complex conjugate of different rows or different columns are taken. So sum of all the terms in this becomes 0. So let's take the assessment question. So what are the drawbacks of Z, Y, H parameters at microwave frequencies? So since Z, Y and H parameters are useful at low frequency measurements, we cannot use those parameters at microwave frequencies. And what is the uniqueness of S parameters? So S parameters are particularly used in microwave frequencies, where we can apply S parameters based on the incident and reflected base, and discuss the properties of S matrix. So we have discussed 4 different properties: unity property, symmetry property, and also square matrix. So and also it is symmetry for reciprocal network. Thank you for listening.